Hello everyone, and thank you very much for giving me this opportunity to present myself. We are the Omnilert Systems Engineering Private Limited Incorporated to tap the potential of what others don't see while observing the same process, technology, and happenings around us and put ideas into solutions to the industrial problems. We have solved the biggest problems in the imaging industry. In this direction, we have developed a unique-to-the-world product designed for prototyping. Currently, we have one director as an OPC and there is a scope for the co-founder or inventor and expert. Team accommodates engineers from specific fields such as mechanical engineering for design development, animations, and simulations. Engineers from information technology, CSE, ECE, for networking, software development, and full-stack programming are essential. In the future, we opt for own electronic hardware and this position will be created. Business development and marketing executives, optical engineer, chartered accountant, and company secretary make a good team. A normal imaging camera has a high-speed sensor such as IMX273 fitted into it. It captures particles in motion. As the speed of the objects increases, the speed of the camera isn't enough. It causes the motion blur. So, the imaging speed has to be increased up to 220 fps to capture sharp images. At lowest speed, images have a 4000 resolution, and at a high speed around 220 fps the resolution goes down and it may not be enough to capture a single object in motion. At this speed the resolution becomes very low as shown in the figure. A motion blur still comes at this point depending upon the speed of the particles. Also, the signal-to-noise ratio have higher chances of deterioration. To alleviate this problem, we came up with a novel solution. Imaging System B is a front-end module that can be used to implement our solution. This module B uses the same sensor specifications and gives highest imaging speed of 660 fps at the lowest resolution. It eliminated the motion blur. It captures images at high resolution of 4000 at highest possible speed in the imaging and machine vision industry. The signal-to-noise ratio is also better in this case. This front-end module has been developed by Japanese and Netherlands company for us and we are in touch with them. The CEO of Omron Centec, Japan, Masumi Kawakami, has invested in this front-end module and heavily recommended it for the business growth. Dick Godrian worked in machine vision sector for 30 years and has incorporated a new company in Netherlands that deals with this front-end module. We have 3 patent publications in this area. Teledyne Photometry in UK came up with their own version of front-end module in the field of optical microscopy. Our methods can be incorporated into it very cheap. Its price quoted by them is Rs 26 lakhs for sale in India. Fuavision company from Netherlands and Pure Spectra from Japan have manufactured a complicated prism assembly to fit into their version of the front module equipped with electronic sensor module and the processor adapter. To achieve this, they have built a robot to facilitate accurate alignment between optical components. It is compatible with the existing NVIDIA boards. Another company in UK has shown their own version of triple-speed front-end module with data acquisition system. It equips IMX273 sensor. What we need here is to implement our algorithms, firmware versions, and software to activate the high-speed imaging option. This saves our 80% of work and time. Our multi-channel or multi-lane method of image data acquisition has been brought into reality by Sony Semiconductor Solutions Corporation and has manufactured image sensors accordingly. Sub-LVDS system though allows simultaneous multi-lane data acquisition, it causes more power consumption. It allows an effective data transfer rate of 30 Gbps at 1 Gbps per lane for 30 lanes. However, multiple lanes require wiring of equal lengths and additional packages are required. All the multi-lane MIPI and MIPI-CSI image sensors employ our method. This method still has speed limitations though the package readout speed is high. A clock is not embedded here. This arrangement is good for monocam version and twin cam version is not required. Canon also employs our method in its 250 megapixel CMOS camera sensor LI8020SA. Our method has been standardized under a term SLV-SEC by the Japan Industrial Imaging Association for sensor manufacturing. The term SLV-SEC stands for Scalar Low Voltage Signaling with Embedded Clock. Sensors have been designed and manufactured to make them ready for implementation of our method as mentioned in the patent publication. In Figure 1, one sensor with multiple data lanes enables a fast and easy data transmission at 30 Gbps with 4.75 Gbps per lane. It has an embedded clock and this makes errorless data transfer possible even with the unequal data wire lengths. Figure 2 shows two versions of the system under the multi-lane functionality with SLVSEC and MIPI or MIPICSI mode. First one is a multi-interface version and the second one is a multi-sensor version, causing the image data transfer rate as high as 60 Gbps onwards. This eliminates a need for twin-cam imaging using a complicated prism arrangement. And here is the feasibility study in captured shots during optical microscopy. The validation of the claims has been given by Teledyne Photometry in UK. Channel A gives an image identical to the image obtained by Channel B. The Channel B either shows some particles having low velocity and high velocity, or the slight out-of-focus alignment error. The Poor Vision and Pure Spectra modules have shown two identical images of fruit basket captured through the prism lens arrangement present in their own version of the front-end module. Here we see the target market and the application field where product can be either used or extended for its use. It can be customized for the automation industry. Optical vibrometry is useful in several applications such as preventive maintenance and industrial vibratory feeder trays. The invented method can be useful in the Android phones or mobile phones, industrial high-speed quality inspection, packing, robotics, food industry, microscopy and spectroscopy. Drone mapping are a few examples where we can target our existing product or customize it further. Sensors based on SLVSEC or multi-lane techniques as mentioned in our patent publication facilitate their use for our monocam systems. We have several options under go-to-market strategy. Advertising through news channels or videos by famed ones is a good method to pull the attention of customers. For example, influential minister has taken a note of Barrow's system and it has made into the news. There is no need to pay more for it to come into the newspapers and YouTube channels. Our front-end module has already hit an international technical exhibition on image technology and equipment in Japan, held recently on 7 to 9th of December 2022. Please kindly take a note of it. Such exhibitions are the hotspots. Under the sales revenue model, we can sell online or offline, and the marketing could be by the mixed means. A mobile image sensor deteriorates in performance with age, and so do the components. This opens up space for us to update the products and convince the existing customers to buy new versions from us. At present, we have put amount through a bootstrap mode into this business. Paid-up expenses are around 2 lakh rupees, whereas the running expenses are around Indian rupees 39,000. Total annual costs are estimated of around 14 lakh rupees, including beginning-level salaries of around 13 lakh rupees. Product development costs are around 6 lakh rupees. Hardware purchase and manufacturing costs are estimated to be around 6,50,000 rupees if we opt to go for imported front-end module and do not manufacture this module here in India. So, our total startup expenses are from 20 lakhs to 26 lakh rupees only. At this stage, we don't go for experienced experts as their salaries are higher. The advertisement-related expenses are kept minimum till the execution or launch of the product. Projected net income post-first year is as displayed. The exit policies may be by means of the merging or IPO.